Hey there, and welcome. Today we're diving into two of the most important ideas in all of math, area and perimeter. These concepts are basically the toolkit we use to measure, build, and understand the world around us. From how you lay out a room to how a city is planned, it all comes back to this. So let's get into it.
So how do we actually measure the world? It's a question we answer all the time, probably without even realizing it. How big is this room? How far is it to walk around the park? And the language we use to get those answers? It's math. And it all really boils down to two fundamental ideas. So here's our game plan. We're going to start with the absolute basics. What's the difference between perimeter and area? Then we'll see how those ideas work with triangles, the building block for pretty much every other shape. After that, we'll jump into quadrilaterals, tackle a few special cases like circles, and then the fun part. We'll put it all together to solve some real-world puzzles. Okay, let's dive right in with the fundamentals, perimeter and area. Seriously, understanding the difference between these two is the key that unlocks everything else. Once this clicks, you'll find the rest of geometry makes a whole lot more sense. The best way to think about this is super simple. Just picture a backyard. The perimeter? That's the fence. It's the total length you'd need to walk to go all the way around the edge. It's a distance. The area, on the other hand, is the grass inside the fence. It's the amount of space the yard takes up. One's the fence, one's the grass. Simple as that. All right, next up, the mighty triangle. And we call it mighty for a really good reason. You can basically build any other shape with a flat edge, what we call a polygon, just by sticking triangles together. It really is the ultimate building block in geometry. So, you've got a triangle. How do you find its area? Well, it turns out there isn't just one single way to do it. The best tool for the job really depends on what information you already have. Let's look at the two most common formulas you're going to need. So the first one is probably the one you remember from school. Area equals 1/2 times the base times the height. Now, the key thing here, and this is super important, is that the height has to be the perpendicular height. That means it has to form a perfect right angle with the base. We sometimes call it the altitude. But what happens when you don't know the height? What if all you have are the lengths of the three sides? Well, that's when you bring out the secret weapon, Heron's formula. Now, I know it looks a little complicated, but it's an incredibly powerful tool that lets you find the area without needing the height at all. Okay, time to put that secret weapon to the test. Let's solve a quick puzzle. We've got a triangle with sides measuring 9, 12, and 15 centimeters. We have no idea what the height is, so this is a perfect job for Heron's formula. Our strategy is super straightforward. We can break it down into 3 simple steps. First, we need to figure out that S value, the semi-perimeter. Then we just plug all our numbers into the formula. And finally, we just crunch the numbers to get our answer. Okay, step 1, find the semi-perimeter, which the formula calls S. Now that sounds fancy, but it just means half the perimeter. So we add up our sides, 9 plus 12 plus 15 gives us 36. We cut that in half, and there's our S value, 18 centimeters. Easy. Now we plug everything we have into Heron's formula. So that's the square root of 18 times, 18 minus 9, 18 minus 12, and 18 minus 15. You run the calculation and boom! The final answer is 54 square centimeters. See how cool that is? It's a perfect example of finding the area without even needing the height. All right, we've pretty much nailed the triangle. So let's broaden our horizons a bit and step into the world of quadrilaterals. The whole family of 4-sided shapes. And while they all have 4 sides, the way we find their area can be pretty different depending on the shape. This little table is a great cheat sheet. For a rectangle is just what you'd expect, length times breadth. A square is just a special kind of rectangle where all the sides are equal, so its formula is even easier, just side squared. Now, a parallelogram, that's like a slanted rectangle. That's why we use its base times its perpendicular height, not the length of the slanted side. And then you've got the rhombus, which has its own unique formula using its 2 internal diagonals. Each shape has its own little trick. Next up, let's tackle 2 special shapes that you're going to see everywhere. The trapezium, with its pair of parallel sides, and of course, the perfectly round circle. These guys have their own unique rules for finding area. The area of a trapezium can look a little tricky at first, but there's a really intuitive way to think about it. You just add the lengths of the 2 parallel sides together, divide by 2 to find their average length, and then you multiply that by the height. It's actually a pretty logical formula when you break it down. And then we have the circle. Its area is calculated using one of the most famous and honestly most beautiful formulas in all of mathematics: pi times the radius squared. It's just amazing how this simple equation connects a circle's radius, that distance from the center to the edge, to the entire space it holds. Okay, we've officially gathered all of our tools. We understand triangles, we get quadrilaterals, we've even handled circles. Now comes the really fun part. Let's actually apply all this knowledge to solve a practical, real-world kind of puzzle.
So here's a classic problem you'll see a lot. We've got a rectangular field, and there's a path with the same width all the way around it. Our mission is to find the area of just the path. Now, there's no single formula for path, right? So this is going to take a little bit of clever thinking.
So the key here isn't about memorizing a new formula. It's all about the logic. The strategy is to see this problem as two rectangles. First, we find the area of the big outer rectangle. That's the field and the path together. Then we find the area of the smaller inner rectangle. That's just the field. And finally, we just subtract the small one from the big one. Whatever is left over has to be the area of the path. So we just follow our game plan. We calculate the area of the big outer rectangle. Then we get the area of the inner one, the field itself. We subtract the smaller number from the bigger one, and there's our answer. The area of the path is 400 square meters. It's a perfect example of how you can solve a more complicated problem just by combining simple shapes.
So what are the big things to remember from all this? First, that core difference. Perimeter is the boundary around a shape. Area is the space inside it. Second, every shape has its own special formula, its own key to unlocking its area. Third, always be on the lookout for the simple shapes that might be hiding inside a more complex problem. And finally, don't forget that having the right strategy is just as important as knowing the right formula.
And that brings us to one last thought. Just for a second, look around whatever room you're in right now. Look at the door, the window, the screen you're watching this on. What shapes do you see? And after all this, how would you start to measure them? The world is absolutely full of geometry, and now you have the tools to figure it all out.